Hello, everyone. Hello. Hello. Microphone. Hey, Mr. How are you? Mr. Fish is on sound. There it is. Where's the sound option? Here it is. Sound. Input. Hello, 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 hello. Hey, Frog. Hey, Comp116. How are you? Okay. Ooh, is this better? Or is it worse? Audio, better or worse? Hello? Hello? Same? Better? Better or worse? Oh, hello? Does it sound any good or does it sound like crap? Ooh. Alright, this sounds way better. Way better. Hey, Social. Hey, Chrome. Okay. Yeah, I think I've been dealing with sound issues for the last couple of weeks. I like to be loud enough. You'd like to be loud enough. Sometimes to a point where it's obnoxious. Because what is it? When you stream, you can't really have bad audio and bad video, either one. Better, I think. Okay. Better. Any better? This better? Much clearer? Or is this too loud? Too loud? Too loud? Anyone? Chime in. Louder, definitely. Okay. Let's make it here. Let's leave it there. Okay, so it sounds like the mic check is good, and we're using the Brio, the USB. Okay, this is good. All right. Okay, one more, the video check. Now we got lighting. Okay, you got lighting. Okay, Bo, CTG, how are you? How are you? We got a long day today. Hello, everyone. Welcome to Introduction to Security. I'm Ming Chow, Associate Teaching Professor at Tufts. Yes, episode 4. We're already on the 4th episode. Hey, Anonymous Worshipper, how are you? Okay, make sure that the video and audio is good. If the audio sounds terrible, please chime in. I've been a little bit worried about the audio for the last couple of days. Like, to a point where it's like, do I need to buy a mic? I mean, today is going to be, well, this is, a topic that, it may sound like really sinister, and it is. Today is about distributed denial of service attacks and how to take down the internet. Yeah, that's going to be the topic. In fact, we have a guest speaker coming today. We have a guest by way of video form, the legendary and luminary John Hammond. And we're also going to use Python and Scapy today. Yes. Hey, CISO Global. We are going to use Scapy and Python today. So it's going to be a very dense day. So let's get started. What is a denial of service attack? And a denial of service attack, DOS, means, well, you're denying. Does it work? Uh-oh. Yep, it does. I'm just trying to post a link. Denial of service means prohibiting or not having access to a particular service. I mean, people freak out these days when, Netflix goes down, Facebook goes down, GitHub goes down, Gmail goes down. I mean, these are resources that you typically have, but all of a sudden they go down, and it's like you can't access them. That raised some, questions. But a distributed denial of service attack means many okay, many computers target a victim or service to bring it down. A CISO Global. And the analogy that I like to bring up, that I use to describe distributed denial of service attack is, so CISO Global. I have a spring water bottle, plastic Poland spring. Oh, well, let's plastic spring water bottle. Let's not get into any companies or anything. So if I throw a empty plastic spring water bottle at you, CISO Global, will you get hurt? If I throw an empty spring water bottle at you, will you get hurt? Maybe, but not that much. Okay, you're gonna get hurt. And maybe not, maybe, but not much. But what if 1,000 people threw a empty spring water bottle at you? What if 1,000 people threw a empty spring water bottle at you? Now, okay. Now, what happened if 100,000 people threw an empty spring water bottle at you, CISO Global? Uh-oh. Now we've gone from 1 to 1,000 and now 100,000, then you'll be dead. Yes. Okay, so you see the escalation of spring water bottle, empty spring water bottle being thrown at CISO Global. But now we can also talk about, what if we didn't throw empty spring water bottle? Is there a way that we can, bring down CISO Global even quicker? And the answer, of course, you just fill up the spring water bottle, or fill up the spring water bottle, ideally with liquid. Then it could really, really hurt even the first couple of spring water bottles. But that's what distributed denial of service is like. And as you can see, it generally, from Cloudflare, is a malicious attempt to disrupt the normal traffic of a target server, service, or network by overwhelming the target or its surrounding infrastructure with a flood of internet traffic. That's what distributed denial of service is. But why? What's the whole point of bringing down a target? Well, number one is to bring down a target. And if you render a target or service inoperable, you cause chaos. If it is a small business or large business, it's a lot of revenue gone. It's a lot of revenue gone. So it's disruption, chaos, loss of revenue, and it's still a tool and a trick of many criminals. Still happen all the time. So now let's talk about, how do you actually conduct a distributed denial of service attack. Let's show how we actually conduct a distributed denial of service attack. And yes, we will kind of continue the analogy of the spring water bottle. Have there been cases of corporations DDoSing each other? The answer is, I have heard. It's good that you asked that. I've definitely heard of one. I just can't think off the top of my head. I know this has happened before. It has definitely happened, but can I find the article? I'm not sure. It's funny that you had to bring that up. I don't know if CISO Global have any cases off the top of head. I'm not sure, but it's definitely I'm sure it happened. So let's talk about how you conduct a distributed denial of service attack generally. Generally, there's a number of ways to do it. One way is to just send a whole slew of TCP sync packet called the TCP sync flood. In fact, later on, you will see how you can do this programmatically using Python. But the most sinister type of distributed denial of service attacks these days happen in the form of something called amplification attacks. And this is one of my favorite articles of all time because it is very, very well written and descriptive to anyone can understand. The idea of an amplification distributed denial of service attack is exactly the idea of the spring water bottle that we have been using to hit CISO Global with. Okay? Now, we're going to look at two different types of amplification attacks, two of the common ones. The first one, it's a brief history of time. Okay? So, we'll talk about DNS amplification attacks in a little bit, but let's start off with Smurf. And for those of you who grew up with Saturday morning cartoon, this should bring back very, very fond memories. Okay, the original amplification attack was better known as a Smurf attack. Smurf attack uses ping or ICMP request, and you'll understand why. Not only why ping, but also why ping is now blocked on many systems these days. And I believe that CISO Global mentioned this last week, that a lot of systems now turn off ping for basically this reason, because ping was so abused for years. ICMP request, and this writing says, to the network broadcast address of a router configured to relay ICMP devices behind the router. Here is the key. The key is the attacker spoofed the source of the ICMP request to be the IP address of the intended victim. Since ICMP or ping does not include a handshake, because ping and ICMP are on layer 3 of the OSI model, the network layer, does not include a handshake, the destination has no way of verifying if the source IP is legitimate or not. The router receives the request and passes along to all the devices sitting behind it. All devices can now respond back to the ping. Now, the attacker is able to amplify the attacker by a multiple of however many devices are behind the router. Okay, so if you have five devices behind the router, then the attacker is able to magnify the attack by 5 times. Now, this is a diagram of the Smurf attack. So let's say I'm the attacker and the victim. I'm the attacker and the victim is CISO Global. And the IP address of CISO Global is 9.9.9.9. I repeat, in this case, we're going to pretend the victim is CISO Global, and CISO Global's IP address is 9.9.9.9. So what I am going to do is I am going to send a ping, P-I-N-G packet to 1, 2, 3, 4, 5 devices. However, each of the pings will have the source IP address actually spoofed to be that of CISO Global, 9.9.9.9. And so each and every one of these devices will actually receive a ping from me, the attacker, but each and every device will take a look and say, hey, this ping packet actually came from 9.9.9.9, the victim, CISO Global. And so all these devices are going to say, okay, I'm going to send a ping back to 9.9.9.9. And all of a sudden, the victim, in this case CISO Global, is going to receive a whole bunch of ping replies. And it's like, what the hell is going on? Bam. So I can use 5 devices. Hey, I can use 10 devices, but the more the better. The more devices, the better. So the more devices can send traffic to 9.9.9.9 or CISO Global. This was the attack that took down a place called, anyone have heard of the White House? The U.S. The White House, where the President of the United States lived back in the 2000s. This was the attack that was used. Now, the thing is that Smurfs are largely a thing of the past because most network operators have configure the routers and system to not relay ICMP requests sent to a broadcast network address. However, even as this amplification vector has closed, others remain wide open. Okay, so, alright, so ping is largely a thing of the past. So what else can we use? Well, okay, can anyone think of a service? Now here is the caveat, the huge key. Since ICMP does not include a handshake, the destination has no way of verifying if the source IP is legitimate or not. Can anyone think of another service that we can abuse and that is still used often enough these days, if not all the time, that you can actually forge or spoof the source IP address? The hint is, think of services that will not use a TCP three-way handshake. Anyone think of one? If you says DNS, domain names, yes. UDP is correct. Mr. Fish said is correct. There's no handshake. UDP is correct. Social Nila, DNS, yes. Okay. In fact, DNS can use both TCP and UDP, but most often or not, UDP is used because UDP is very fast. So combine what Social Nila said and Mr. Fish. DNS. DNS uses UDP. So yes, UDP, unlike TCP, has no handshake. Therefore, you can spoof the source IP address. Now, Social Nila. I'm going to clear my screen. I got my terminal open. And anyone know how to do a DNS lookup on the command line terminal? Anyone know of a command that you can do DNS lookups? Mr. Fish says dig. CISO Global says dig. Crumb says NS lookup. We can do that. However, I'm going to give Crumb the benefit. Yeah, you can do NS lookup or dig. But in this case, size matters. The number of characters matter. So we want to make sure that our input payload is small. NS lookup has how many characters? 8 characters. Dig has 3. We'll use dig because it has 3 letters in the command, not 8. Okay? But yes. So you'll understand why size matters. Okay? Small or big. And dig. Dig is a NS lookup utility. Okay, Kurum, what is your favorite domain name? I'm going to give you the consolation prize. Give me your favorite domain name. Give me your favorite domain. Okay, you got sense. Oh, God, they censor it out. Okay, let's do dig. Well, I'm not going to, I think if I use 4chan, I get banned. Let's not do that one. But let's do reddit.com. Dig space reddit.com. How many characters is that? 1, 2, 3, including space, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 characters? Around 15 characters. Oh, Discord. I think Discord is the same character. 15 characters here. Right? If you count 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Now, 15 characters as your input. But your output has all these characters. How many is that? The input is 15 characters. The output has 574 characters. That's a lot. 574 divided by 15. That's what, 38 times? Yeah, 38 times amplification. So now we are moving to a point where, remember the analogy that I was using of throwing a empty spring water bottle? But now, imagine we're trying to fill up the spring water bottle and throw it at someone. Okay? So let's talk about DNS amplification now. What we just did. DNS amplification is there are two criteria for a good amplification vector. Number one, the query can be set with a spoofed source IP address. So by way of a protocol like ICMP or UDP, very good, Misra. That does not require a handshake. And two, the response to the query is significantly larger than the query itself. DNS is a core ubiquitous internet platform that meets the criteria. There you go. DNS queries are typically transmitted over UDP, meaning that, like ICMP requests used in the Smurf attack, they fire and forget. Okay? Therefore, you can spoof the source IP address of DNS, and the receiver has no way of determining its veracity before responding. DNS is also, as we just saw, capable of generating a much larger response than the query. So, for example, here is the input, and you get back this gigantic output. Okay, that is a 64-byte query that resulted in a 3,222-byte response. In other words, an attacker is able to achieve a 50-time amplification over whatever traffic they can initiate to an open DNS resolver. And now this article also talks about open DNS resolvers, the bane of the internet. This is still a thing, believe it or not. Okay? Distributed denial of service happens all the time, every second. Okay? So now, you may be wondering here, I showed you how to use, we just used DNS. We used ping last week. So you may be wondering, can you do distributed denial of service attack using Python? Can you write one yourself? Yeah. What if I told you that to do a DNS amplification attack, it only is a few lines of code? Yeah. Yes, we're gonna show you how you do DNS amplification DDoS programmatically using Python in a few moments. Yes, we're gonna do that today. We're going to show you the code. It's only a few lines of code to do that. But before we do this, actually, we're not only going to do DNS amplification DDoS, but also sync flood as well too, which is a very, very classic and common DDoS attack. Well, you can do that in Python and Scapy. And now, I'd like to introduce you to Scapy. I call it Scapy. Some people call it Scapy. Okay, so what is Scapy? Scapy, go to scapy.net. Scapy is a Python library, okay, that will allow you to do packet manipulation. So you may be wondering, does that mean that I can create packets in Python? Yep. Using Scapy? Yep. Can I send packets? Yep. Read packet? Yep. Forward source IP addresses? Yep. You can do that. So the Wikipedia is that Scapy is a packet manipulation tool for computer networks, originally written in Python by Philip Biondi. I think it's Biondi? Yeah. Scapy.net is the website. And I had to work with Scapy a lot this summer. Scapy, of course, because it's a Python library, is also free and it's open source. Now, one of the biggest complaints of Scapy is that the documentation can be a lot better, and I would agree with that. I think that's generally the common feedback about Scapy. So, Scapy website looks cool, scapy.net. It is a powerful interactive Python manipulation library written in Python. Scapy is able to forge or decode packets of a wide number of protocols, send them through a wire, capture them, yada yada yada. Scapy can be used as a library or even as a command line tool, command line interface. Scapy is also cross-platform. And here's a little screen on how you use Scapy at the very basic level. There's the documentation. They're a good introduction, but we're going to give you, and I'm going to give you an introduction now. So I am on Mac OS. And now I want to give everyone a little heads up, a little bit warning. Things have changed recently. The latest version of Python now is, if you go to python.org, I think it's Python 3.12. It is, go to Python, go to downloads. It's now Python 3.12.6. Why am I showing you this? I mean, yeah, you have to download Python. Isn't that installed on most systems? The answer is no. The answer is no. By default, Python, I believe on most Unix systems or Linux system, is still the older version. That's number one. I don't think Mac OS even, I think Mac gives you like a really old version of Python, and for Windows you have to install it yourself. Python 2 is no longer supported, it's deprecated, so we have to use Python 3. Now the latest version of Python 3 is Python 3.12, which is very different from Python 3.11. Perhaps the biggest difference in Python 3.12 is you are now forced to use what is called virtual environments. A virtual environment is, think of it as a sandbox that you have to create, and where anything that you do, any Python libraries that you download won't affect the system at all, which is a very good thing. This is a really good thing. Back in the days with like Python 3.11, you can install like Python tools and Python tools and stuff, and it can really mess up your system. But now Python 3.12 forces you to use a virtual environment. This also means that I have to do a little bit of extra work to show you how to actually set up Python and Scapy. And yeah, 2.7 is no bueno these days. I mean, they don't use Python 2 anymore I mean, it's deprecated, all right? Yeah, it's deprecated. And Apple is always notorious for installing really old software development tools. I have to give you now the instruction on how to actually install not only Python, but also Scapy as well. So as you can see, my desktop is empty. My desktop is empty right now. So what I am going to do is I'm going to cd tilde to my desktop. I got nothing here, which is good. Now I'm going to, first of all, install Python, the latest version of Python, which is 3.12 whatever it is. I use Homebrew on Mac OS, which is the easiest way to install any sort of software, so I do brew install Python. And once I do that, you can say, okay, Python 3.12.6 is already installed and up to date. Great. I'm not going to reinstall. So now, this makes sure, now I have the latest and greatest version of Python 3.12 installed on my Mac. Okay? I can check if I am running Python 3.12 if I type Python 3. What this will do is open up the command line interface, what is this tool called? The interactive Python. So you can type in Python command and test out stuff. And as you can see, I am using Python 3.12.6. Good. Now, if you do have a mismatch of version, you need to take a look at where Python got installed to, and which is the default version. To quit out of this, just type exit as a function, and there you go. So I'm using Python 3.12. Now, if I type Scapy on my machine right now, command is not found. Good. Okay. So now what we're going to do is on my desktop, I'm going to create a brand new folder called alarm. There it is. I got my alarm. Yeah, I mean, it's okay. Virtual environments, I think in Anaconda Land, I'm not entirely sure, But Anaconda, I believe it is the latest version. I'm not sure what it is, but I think they force you to use virtual environments anyway. So I'm going to create a new folder called alarm, and now I'm going to cd into alarm. And of course, there's nothing in the alarm folder. Now what I am going to do is I'm going to create a virtual environment inside of the alarm folder. So a virtual environment, think of it as a sandbox, where it will have the Python tools, it will have the Python interpreter, and then you can install any libraries that you want without affecting the entire system. So how you enable and install a virtual environment inside of a folder or for a project is type Python 3 space -m for module space venv for virtual env, and give it a name of this environment. We'll just type env. Okay, so now notice what happens. Bam. Now if I do an ls, you notice on ls-l I have a folder called env. ls-l env, and you can see it has the folders bin, include, lib, and that should install all the Python tools for you. Yep, I got pip, Python, an alias. Yep, because they're all aliases. Good, good, good. Now the next step is I have to activate. This is very important. You need to activate the virtual environment. Source env, source space env /bin/activate. You need to activate the virtual environment, and notice that now I have, before my prompt, I see a command. I see env inside parentheses. This shows that the Python virtual environment is now activated. Now to deactivate it, so you go back to not using a virtual environment in Python, type deactivate. Now I'm going to activate the environment again. Good. Now I'm going to clear. Now I have my Python virtual environment activated. Now if I type Python 3 is 3.12.6. Okay, excellent. But however, if you type which Python 3, you'll notice is that the version of Python is going to be used in the virtual environment. Now if I deactivate this and I do which Python 3, you will notice it's going to use my system Python. You can see when the difference now of which Python is being used, depending if you either A, use a virtual environment or you don't. So I'm going to activate my virtual environment again. Which Python 3 is the one inside env bin. So I'm using my virtual environment Python, not the system Python, which is good. Next step is install Scapy. Pip install Scapy. And that's it. Now what happens if I type, actually, let me deactivate my environment so I'm not using a virtual environment, and I type Scapy. As you can see now that the command is not found. Notice that I am still in my alarm folder, and now I'm going to activate my virtual environment. Now if I type Scapy, notice what happens. Boom. Welcome to Scapy 2.5.0. This is the command line version of Scapy. This is where you can do things like, create simple packets, send packets, you name it. Okay? If you're doing like few lines of code for testing, you can use this interface. Okay, so now how do I create a packet? How you can create a packet in Scapy is, well, first of all, you have to know a little bit about packets and also a little bit about the OSI model. So if I go to scapy.net here, Scapy, how you create a packet, you take a look at the if you take a look at the little demonstration here, it uses this layering syntax. So you can actually specify the different layers of a packet, like the network layer, the transport layer, and even the application layer. Think the OSI model. So let's actually go to, I'm going to open up the documentation here. Interactive tutorial. So how you build a packet is, okay, let's build a packet, let's play with it. In this case, it's just creating a IP packet. Yada, yada, yada. Yes, here it is. That slash operator. The slash operator in Scapy is used to composition between layers. When doing so, the lower layer can have one or more of its default field overloading according to the upper layer. You can, and all that stuff. Okay, so let me give you an example. So I'm going to do packet equals IP for the IP layer. And I'm going to set the destination to be 192.168.1.219. So you notice the syntax here. If you notice the syntax, it is DST is the field name, and you set it equal to an IP address, which is inside of single quote, which is a string. Now, okay, IP packets are not that interesting because I've got to do something, but what about if I want to create a ping packet? Well, you use the slash operator, and you do IC, and then you do ICMP all caps, and that's that. And so, my friends, we just created our very first packet in Scapy. And this packet is one single packet with a destination of 192.168.1.219, and it is an ICMP or a ping packet. Okay, so I can do, if I can just type packet again, what it will show you, here it is. This is an ICMP packet with the destination 192.168.1.219. I know that is one of the machines on my home network. Okay. If you want to print the all the layers of a packet, if you want to print all the layers of a packet, what is it? What's the field? I don't want a graphical dump. Okay. One-line summary. Okay, here it is. A one-line summary. Packet.summary. This isn't going to work. Okay, though it does work. Oh, packet.summary. So you should do packet.summary with the parentheses, where summary is a function. And so here it is. This is an ICM. Okay, this is the same thing as you print out packet, essentially. But what happens if you do packet.show? Packet.show. And now you can see the different layers. So the IP layers, the ICMP layers. If you don't specify a source of the source IP address, it will use your machine's IP address by default. Okay. Now to send the packet, I'm going to open up Wireshark. I'll just show you what happened behind the scene, and I'm going to be sniffing on EN4. I'm on wired. Too much for all the traffic between my computer and Twitch right now. But I am only going to show ICMP packets. Is this the beers on the wall again? Yep. Alright. ICMP and IPADDR equals 192.168.1.219. I only want to see ping packets to the address 192.168.1.219. And now I'll leave this open. Okay. So I'll have my Wireshark window open. I have my terminal in front. To send a packet, I use a send function. I'm going to send packet, and now notice what happens. Ready? Watch what happens. When I send this ping packet, that is addressed with a destination to 192.168.1.219. Boom. Sent one packet. As you can see, I sent a ping packet. Remember, there's only one. It's not going to be like a run of ping packets. You can see that the source is 192.168.1.244. That's my machine, and the destination is 192.168.1.219. You can also see that the source is 192. I got a reply back from 192.168.1.219. Okay, that's nice. Okay. Now, remember how I said you can use Scapy to forge the source IP address? You can do that. We're going to do that now. So this time, this thing's wonky. Okay. So I'm now going to create packet equals IP, src equals 8.8.8.8, which is the Cloudflare DNS IP address. DST equals 192.168.1.219. ICMP. Hit enter. Type packet. Packet.summary. Packet.show. The function. Notice now the source IP address is no longer my 192.168.1.242. It is now 244. It is now 8.8.8.8. And the destination is still 192.168.1.219. What happens if I send this packet now? But remember, knowing that the source IP address is 8.8.8.8. Watch what happens. Boom. As you can see, the packet that got sent out was a ping packet to 192.168.1.219. But the source IP address is 8.8.8.8. Now, as you can see from Wireshark here, the request, you can only see the request packet. You won't see a reply because the reply is going to be the machine at 192.168.1.219 is sending to 8.8.8.8. I can't see that on this end. Now, if I want to see that packet that is sent, the ping reply sent to 8.8.8.8, I need to SSH and log into 192.168.1.219 to see that happen. So this makes sense. Because I forged the source IP address of the ping packet to be 8.8.8.8, you're only going to see one on Wireshark on my end. So that is how easy it is to just spoof the source IP address of a packet. Just change the SR, like you can just modify the source IP address, and that's it. Okay, now I'm going to exit out of Scapy. And okay, this is nice. Nah, I'm going to stop and quit without saving. Now, okay. Generally, a lot of people use Scapy programmatically for Python programs. In the fourth lab of this course, you go to cs116.org, go to lab number 4, you're going to write, the students are going to write what is called an incident alarm. Here's the full assignment spec. This is a full assignment specification. Now, think of it this way. In the second lab of this class, students had to actually do packet analysis using Wireshark. So the second lab of this course was to use Wireshark. You could also use other tools like EtherCap, BetterCap, whatever it is. But what if I told you that for the fourth lab, you're basically writing a tool like Wireshark? Yeah, The incident alarm, what students have to write, is basically an El Cheapo or a very, very small version of Wireshark or BetterCap or EaterCap or any packet analysis tool. So now, instead of using the tools, you actually have to write one. And you can write tools that read and write packets, using Python and Scapy. Okay? Now, for this lab, ideally you also want to be using the PCAPs from the second lab. So the instructions are now spelled out, hopefully pretty deeply now, including how to get started, downloading Python and Scapy. But for this lab, I also give you what is called a starter code. We're going to use the starter code right now. So I give you what is called a working alarm.py program. I'm going to fire up Visual Studio Code. And then now what I am going to do is to now copy this code. Yes, this is starter code that you all can use. Copy. I'm going to save all this as alarm.py and the alarm folder that we had. Save it all, and here it is. I already wrote a lot of it for you. Your job is to modify the packet callback function to detect incidents, like usernames and passwords sent in the clear, fin scan, no scan, Christmas tree scan, someone doing a NICTO scan, anyone trying to connect to RDP, VNC, or SMB. Okay? So now, here, if I do now you can see the alarm.py is in my alarm folder. I copied this from GitHub. Yeah, you know what I'm also going to do? I'm going to do a wget as well to download set1.pcap and also set2.pcap. Okay, so I have set1 and set2 pcap from lab number 2 also in this folder. Okay, so if you take a look at what's in the base starter code in packet callback right now, there is an exception handling, but what it does, like the first thing is, here we go. Each and every packet will go into the callback function. So for every packet in a PCAP file, yes, this alarm can also read PCAP file, with a -R flag. Each and every packet will go to the packet callback function here. The starter code that I provided with goes like this. If packets sub TCP, that means look at the TCP layer. If the destination port is 80, then just print out HTTP web traffic detected. Okay. Alright, so that's what this program, the starter code, does. So I'm going to do an LS now. As you can see, I have 4 files, including the virtual environment file. I still have my virtual environment activated. So now if I do Python 3, alarm.py, hit the enter key, you're gonna get, okay, sniffing on ETH0, which we don't have on a Mac. That's the default, and you're gonna get an error message that says, sorry, cannot read network traffic. Are you root? This is the correct behavior. By default, if you don't specify anything, any flags, it's going to assume that you're trying to sniff network traffic. It doesn't matter if you're reading or you're sniffing, they both go to, like, it's the same function, that same functionality. Both use this packet callback function. Now, if you go to Python 3, go back, and you put a -H flag for help, and what you'll see is this is a network sniffer that identifies basic vulnerabilities. The -H option is this help menu, -I is for sniffer mode, and for -R is to read a PCAP file. So now I'm going to clear the screen. I'm going to go back up again, but this time I'm going to do a -R, set1.pcap. That is in my current folder, and you can see that it read in the entire set1.pcap file, and, well, nothing happens. And this makes sense because set1.pcap does not have any HTTP traffic at port 80. But what about set2? If I now read in, use the alarm to read in set 2.pcap, notice what happened. Bang! You're going to see a whole slew of HTTP web traffic detected. Boom. A lot. Okay. So, alright, cool. Can we do any, what else can we do with this? Okay. So, let's modify this code a little bit. So we can do, if this should be a function in Scapy called hasLayer. Yep. If packet.hasLayer TCP. So this is another way to check if a packet has a layer. So if packet.hasLayer TCP, okay. So I'm gonna let's do some modifications here. If packets of TCP dot dport equals 21, then we're going to print FTP traffic detected. There you go. So now I'm going to clear the screen. I saved my code. So I do Python alarm.py minus r set. No, I'm going to try 1 this time. I'm going to do set 1.pcap this time, and it should say, yep, FTP detected. Okay. Set 2, HTTP traffic detected. Okay. Cool. Wait a minute. So if the packet has TCP, has layer TCP, what you can also do is do like print packet. Now if you want the IP address, you have to specify the IP layer. .src, print packets of IP, DST. Now watch what happens. So this is, we just made the modification of the code to print out both the source and the destination IP addresses. Look at what happens. Boom. And you can print out the source and destination IP addresses. This is going to give you really wonky behaviors, and it doesn't make any sense. Now you can do this, but it can give you some really effed up results. Print the packets of TCP.source and print the packets of this. Maybe I'm going to use this for a job interview question one day for Python. But this makes no sense. But it's still going to work. It should still work. But it gives you like wonky ass behavior. Alright, wait a minute. What's going on? I got nothing now. Maybe it doesn't work, which is the intended behavior. If you get like all of a sudden no results and stuff, one of the things that you really want to do is to what you call print out the exception. Uncomment out the print statement in the exception block, comment out the pass function, run the function, run the thing, and there you go. SRC is the error. I don't know what this means, but it looks like that there is an error of some sort here. There is. There really is an error of some sort anyway. But the source IP from the TCP layer doesn't make any sense. So you got to be very careful on where you're getting data from. Yeah, the source IP address, destination IP address, they're not in the TCP layer, they're in the IP layer. There you go. Works. Set 2.pcap works. Now, if you want to print out all the TCP flags, can you do that? Yeah, sure. Sure you can. Print packet of TCP, the TCP flags. Now watch what happens. So I'm going to do set 1.pcap. And you can see all the TCP flags as well. And they're just a string of letters. Now, I'm just going to pipe more so you can see the very beginning of the output as well. And you can notice what you see. Just have a friendly reminder on what set 1 dot looks like. Sync, ac, and ac. Notice what you see. Sync, ac, and ac. Why always me? Sync, ac, and ac. There you go. First 3 packets. Yeah. So yeah, now you're going to be writing your own version of Wireshark, or an El Cheapo version of Wireshark that also does like incident handling, incident detection as well. So you can also print out text payload, yeah, using Scapy and Python. What is P? Push. PSH. Push. TCP push. PSH. I always forget what it means. Well, so now you have a brief history of Scapy, brief tutorial of Scapy and Python. Now, perhaps it is a good time. Oh, I'm going to deactivate this environment. Exit. I don't need this anymore. I'm going to quit. And now what I want to do is I'm going to turn it over to John Hammond, who is going to talk about how you bring down the internet using Python and Scapy. Where am I? And here we go.
Alrighty, hello everyone. Welcome. Thank you for tuning in. I appreciate you being here. This is a talk and presentation titled Take Down the Internet with Scapy. I'm presenting this as part of DEF CON 28 or DEF CON Safe Mode, and I'm here at the Packet Hacking Village. So let's dive into the presentation, but before we do, I've got to say this. I've said it before, I'm about to say it now, and I'm certainly going to say it again many, many times throughout the presentation. Thank you. Thank you for being here. Honestly, seriously, like, I know things are a little crazy and weird and not how we're used to them being at DEF CON, but thank you so much for being here. Thank you for tuning into this talk. Thank you for being a part of all this. I usually say this at the end, and I'm certainly going to, but now especially, I think it's really important. Just thank you. Thanks for being here. I really appreciate it. Okay. So the classic disclaimer, right? The start of every talk, it's just how it's got to start. These are my words, not my employers. I don't represent them. I'm not speaking for them, etc. This is stuff that I wanted to bring to you, me personally. Other disclaimer, don't or do try this at home, right? Anything that we talk about, anything that I showcase here, obviously it's a talk titled Take Down the Internet. Don't actually do that, or maybe do it at maybe your own small scale lab environment, etc. You can tinker with it and explore with it, but don't actually take down the internet, right? Cool. Next, your mileage may vary. I bring this up with everything that I kind of try and showcase. Look, I'm talking about it and I'm showing it to you. Maybe you'll have different results. Maybe something will work differently or strangely in the way that you do it if you do this sort of thing. I can't promise, and I don't mean to make this any written in stone gospel or anything. The stuff that comes out of this talk, it might be different for you, and your mileage may vary. Okay, last bit. We're the good guys here, right? We talk about security, we talk about cybersecurity, we break things for the sake of making them better, we hack for good. And I want you to do the same. The stuff that we're going to talk about and showcase in this presentation, maybe it's a little bit on the different side of the fence. I want to reiterate to you and kind of enforce it, hey, hack for good. Okay, obligatory introduction, right? Using Python, and we'll dive into that more, but I want to say, the title of this talk, right, the whole theme, Take Down the Internet, that's going to be doing a lot of kind of jerk stuff. It's about obnoxious, annoying, adversarial, and disruptive attacks. So nothing like elite, super cool, 0 days, crazy like Ninja Warrior, cyber hacker stuff, but really just being mean, and breaking stuff. We're trying to recklessly break stuff. I want to showcase some of this to you because really I want to show you just how easy it is and how Python, just the same scripting language that's about on every Unix system, can do this stuff. And how you could do it if you really wanted to, but you shouldn't. You don't have to, right? Take down the internet. Obnoxious, annoying, adversarial, and disruptive attacks. That's the background. All right, now let's talk a little bit about Python. I'm going to be using Python as the vessel for this talk, right? We want to make this a little bit of a technical talk and showcase some code. The website is actually fantastic. They have a page over there called Awesome Scapy, and that will showcase other tools, exploits, and some sample code to use, and it's really, really cool. They have some good stuff on Wi-Fi, like mapping and tracking Wi-Fi networks through 802.11, making a roaming access point, performing some man-in-the-middle attacks, some Tor, onion router protocol stuff, tons and tons of great stuff, even CVEs and exploits for common attacks, or stuff from Crack, the attack against WPA2. Super duper cool. Really recommend you go check that out. Okay, now let's talk about the basic syntax of Scapy, because if we want to use it, we have to know how to. I say that Scapy is Pythonic in that the syntax that it uses when you're working with the module, you're working with Python objects, right? The same way most everything in Python really is that you're interacting and working with an object that has methods and properties and all these attributes and things you could work with that are really under the hood, right? Functions and variables, just with a kind of a different decorated name. But being object-oriented means we can do some kind of nifty things with it. Maybe not all the time. I'm not trying to say OOP is the way, but it's nice to have that kind of built into the language when necessary. So you can see I'm working in like a little bit of a script here, right? I've got a shebang line set up. I'm going to work with Python 3 as my interpreter. And I'm going to use that from scapy.all import everything, or the asterisk, the star, the wildcard, to pull in everything that that Scapy module has into my current namespace so I can interact with it and I can work with it through Python. So here I'm going to create an object or a little variable, ping equals, and the IP, this big class name, right? You can see the capital letters there. That's going to return a Scapy object, and it's going to be a packet, and I can define how that packet looks. Maybe I don't want to use an IP, or maybe it's that specific header for that protocol. I could zoom in on other things between TCP, UDP, HTTP, or anything else. And Scapy already has support for all those crazy cool protocols and layers, and you could just pull them in and work with them. Or if you really wanted to, you could go do a little deep dive, get in the internals, and build your own. So note inside here, I'm creating this IP object, and I'm passing in a keyword argument. I'm saying DST, or the destination IP address. I've simply set that to a string, 192.168.1.1, and I've had a little division symbol, or that forward slash, which looks weird, right? Because we're not dividing these objects, but I'm using that syntax, and that is the syntax that Scapy uses to actually add layers in or kind of build them into that packet that we're crafting. So now I'm going to say this is simply going to be an ICMP packet or ping packet, right? I've assigned that to that ping variable or the object, and I'm just going to print that out on the screen. If I were to run that script, check out down below. Now I have that kind of B prefix to note that this is a binary string, or I'm just including real raw bytes here. And that \x, the \x everything, all those are the bytes to this packet that I've just formulated and created in a super duper simple way, right? It literally took one line of Python code, and now I have a ping packet. And I could do this. I could send this packet. I could receive the information that comes back, maybe a little echo, a request, reply ping. That's very, very cool. All in a script, all automated and extensible, whatever way that I want, and super duper short, right? One line of that Python code, easy to read, easy to write. Obviously, Scapy is abundant, and there are more examples of this sort of thing on their website and their documentation. And that's really, really why I'm pointing you all towards it, because that's where the good stuff is. We're going to cover some cool stuff in the talk, but if you want to go deeper, learn more, do some more research, I'd recommend, hey, go check out that documentation. Okay, last slide on Scapy, I promise, then I'll shut up about it and we can move on. I'm not trying to sound like an evangelist here, but I am trying to show to you all of the cool things that Scapy can do. Handle it. It'll choke. There's so much data in that packet that the machine doesn't know what to do with it, and it'll freeze up or just fall over or crash. We talked about ping packets in the previous example, or that script and source code that I showed you earlier, when we were looking at that ICMP protocol, or the Internet Control Message Protocol. So typically, ping packets are very small, but IPv4 ping packets can be much larger, up to the maximum allowable packet size of 65,535 bytes. Some systems might not be designed to actually handle packets larger than this maximum, and they might be vulnerable to packets at that size, and they're sensitive to it, they'll choke, and they'll fall over. When this large evil packet is sent from the attacker to the victim, the packet becomes fragmented into different segments, each of which will be smaller than the maximum size limit. When the target and victim actually attempts to put these pieces all back together, eventually that total size will exceed that maximum size limit, and maybe a buffer overflow occurs or something goes wrong and that machine can't handle it. It'll freeze, it'll choke, it'll crash. So we're using this example where the ICMP echo or that ping packet could be used for this attack, but really anything that sends an IP datagram that can hold more data or can have this attached information that extends beyond that maximum size could be used for this attack. That could be TCP or UDP or any IPX stuff. Admittedly, the ping of death attack is kind of old and a little outdated, but I think it works as a really cool and simple, quick jumping off point or starting point for us to take a look at some of these evil, nefarious things that we could do with Python and Scapy. So with that said, let's take a look at the source code here. You can see I'm using the send function, which is part of Scapy. We say we've imported everything into our namespace. You could also send just one packet and receive the information back, or send packets inside of a loop. But for just one quick shot, firing the gun, we can use this send function here. We'll create a fragment, as kind of we discussed earlier. Okay, sending fragments that might be rebuilt and reassembled by the victim machine that could potentially cause it to crash and choke. And inside of that, we'll build this ICMP packet just as we've done before in that previous example. However, you can see there at the end, we use another divider or to add in another layer or some more information into this packet. And I just use a simple dummy string. I just use the letter X and I multiply it by this large number. So I have this data payload, this information that I've strapped to this ping packet so that I can send a ping of death that's just a little too big. And maybe that machine is biting off more than it can chew. It'll choke and it'll fall right over. I did mention, though, that this ping of death attack is less common today, right? More so now, you'll see other kinds of attacks that are still this denial of service attack, right? We're being a jerk. We're overwhelming, flooding, and just bogging down the resources on that victim or target. So one of the more common ones you'll see now is perhaps an ICMP or a ping flood. And we can certainly send other kinds of floods. One of the most common ones you might see is a SYN flood. SYN flood is another denial of service or DOS attack, which will make that server, your victim, unavailable to respond. It'll be just too busy. It'll be bogged down. It'll be hosed because something will be consuming all of the available server resources. We're going to cause that by sending packets with that SYN flag set. So you know TCP packets, right? TCP being the transmission control protocol, which ensures there is a connection in place by using the three-way handshake, right? The client on one side of the conversation will send to the server a packet with the SYN flag set. to synchronize or start the conversation and begin requesting communication. The server over on the other end of the conversation will say and respond back with a SYN-ACK packet, or a packet sent with those flags set. Finally, the client, knowing that the server has responded, that someone actually answered the phone, it will respond once more with an ACK flag set on a packet, or the acknowledgement, okay, someone is listening and we can talk, we can have this conversation. Interesting thing though, on step 2 of that process, or in the middle of the three-way handshake communication, the server, while it sends that SYN-ACK packet, it will wait to receive that ACK packet from the client so that it can begin having this conversation. So, the attack is simple. We just send a ton of SYN packets where we're just starting all these conversations. We're dialing the phone, but once someone answers, we don't care. We don't respond to them with an ACK packet. So they're overwhelmed, right? The phone keeps ringing. They're going to pick it up and they're going to want to talk to someone, but no one will be there. They're just not having this conversation, but they're still holding the phone and more are ringing. That will hog all the resources. That will cause that target victim to not be able to respond to other legitimate traffic because, okay, hey, they're busy, tied up with other stuff. All those resources are being utilized right now. Because this attack brings that server to the halfway point in the three-way handshake, right? They've started the communication but have not responded to the server's acknowledgement. That means that it's halfway communicated. That's why it's called that half-open attack. Kind of interesting. So let's take a look at the source code, right? Scapy, again, makes this super duper easy. We're performing this attack in, realistically, 2 lines of code that could even be shortened to 1 because, hey, maybe we could abstract out that object that's not necessary for that SYN flood. We could just pass that to the function. So I'm creating the SYN flood object or variable, right? I send in a keyword argument for the destination. Again, just an IP address we'll use. We'll set an ID number for that packet and we'll specify the time to live. These values aren't extremely important for kind of just our discussion, but obviously that next layer certainly is. We create a TCP portion of this packet, and that sport, or S port is how you should read that, for our source port, that's just going to be a random ephemeral port that Scapy will help us generate with that rand short function there. That'll return something that make it look like, okay, we're coming from a different port every time. The D port, or the destination port, will be passed in as a list or a little Python array. We'll just send this over to port 80 HTTP. You could specify this to whatever you wanted to, maybe SSH or anything specifically. Specify a sequence number, specify an acknowledgement number. Again, for this example, those don't really matter all that much, but maybe they could in other scenarios. The window size, and the most important thing here, the flags that are set on this TCP packet. Obviously, I'm just passing in a string here with that capital S, and certainly enough, that stands for SYN, right? The SYN flag has been set on this packet. So we have created one packet that is just a SYN packet. The very, very first step in that TCP three-way handshake. The next line below, we're going to end up using that SR loop function that Scapy makes available to us. And that is going to send and receive packets in a loop. So we will repeatedly, over and over and over again, send this packet. The keyword arguments there, that inter or the interval, we'll send those at 0.3 of a second. We'll retry every 2 seconds if that kind of gets dropped. And we'll have a timeout of 4 seconds. Again, those are a little extraneous, but the point that we're getting across right now is that we are looping a SYN packet being sent over and over and over again. We are flooding that target victim server with this SYN flood attack. In the case of the line of code there, we have an answered and unanswered information that's being stored as a return value of that SR loop. That'll just return a tuple, okay, or a list of what packets actually had a response and what didn't. The point that I'm trying to get across is that just these 2 lines of code are putting together this attack. And it's super duper simple. All you've done is outlined the structure. You've orchestrated this packet, and now you can put it to work. You can weaponize it as a SYN flood. You might notice, though, in this example, with this setup right here, we're sending this SYN flood attack just with our attacker machine. One machine. So potentially, that endpoint or that target, the victim server, once it realizes, hey, I'm under attack, right? I'm in danger. If they kind of had the opportunity to look through some logs or could figure something out and determine, oh, I know the source of this attack, I can just block it off. Well, you're totally right. That's absolutely doable. For that reason, this kind of thing isn't often done just with one host, just with one attacking machine. So you bring into the conversation, okay, we're performing a denial of service attack, a DOS attack or a DOS attack. But if we had more machines in this pool, if we were attacking with multiple hosts, we could be performing a distributed denial of service attack, or that DDoS, DDoS. That might make it a little bit harder to do, harder to track down, harder to trace. However, we could do even more. We could go one step beyond that when we say our source IP address, we don't want that to look like it's coming from us. We want to hide it. We want to mask it and obfuscate that just a little bit more. But you can tell with Scapy, we are crafting our packets at the granular level. What's to stop us from specifying just that information, just the bytes, the real information that we need within that header of the packet? We could say that our source IP address comes from a different IP address, comes from a different host. We can spoof our IP address simply by passing in the keyword argument. Just as you see the example there, we specify that DST keyword argument as an IP address string. We could just as easily specify SRC, or the source IP address, and make it look like we are coming from a different location. We can spoof our IP address super easily with Scapy. And we can use that as a segue into the next attack, DNS amplification attacks. A DNS amplification attack is a really interesting technique that abuses the regular functionality of DNS, or the domain name system, to again overwhelm, spam, and flood a target or victim machine. The way that this works is that the attacker actually sends a legitimate regular request to a DNS name server asking for as much information as they can. So their request is a regular kind of small, tiny packet just asking for information, and the domain name server will respond with as much information as possible, and that way you get a much larger packet in response. The trick here is that with this DNS amplification attack, the attacker sets their IP address, the source, back to the actual victim or the target server that they're aiming to overwhelm and choke. You can see this here in the source code, right? We're defining, again, another object or variable to keep track of our packet. We're defining an IP header, but interestingly enough, we supply that SRC keyword value, or the source IP address of the packet that we're going to be formulating. Note, this will act as our victim. This is the target machine that will have the domain name server send back that large request. You can see again our division symbol or the / to add new layers, and we're adding a UDP packet portion, right? We'll set the D port or the destination port to 53, the default port for the domain name system or DNS servers. And what we're going to query from this DNS is anything we'd particularly like. Here, I'll just ask for anything regarding google.com or that domain. You could, of course, ask for any type or any resource record you'd like, an A record, a text record, a CNAME record. Generally, with this attack, you could expect to see the attacker request for any, as in return all of the resource records you could give me. We'll have that packet formulated, stored, and encapsulated in that DNS amp object and variable, and again, we will just send that packet along. The DNS server will respond accordingly. It will give all the information it can, but send it to that source IP address, not our actual attacker. that will flood and overwhelm, choke that target victim server. Obviously, you'd want to have more than one attack or one attacking machine doing this. You could perform this distributed denial of service, right? That DDoS, or send this request multiple times. But I think this attack is really cool and really interesting, right? If you put it in kind of layman's term or normal human explanation, say you are at the drive-thru ordering some fast food to go, or whatever the case may be. Let's say you ask the person or the teller that's chatting with you and taking your order, I want one burger, or I want one drink, or whatever. Typically, that job of the teller will read back your order, right? So envision this scenario. You as the driver, right? You as the attacker, you say, I want everything on the menu. And then before they can read your order back to you, you drive away and let that next person go ahead and actually hear all that information. So while you just asked for a small tiny thing and a simple, hey, give me everything you've got, the next person or your target or your victim is going to be read and enumerated and receive all of the information. So maybe, I don't know, what a 1 scale for your packet could respond to a 10 in the response and what that teller will read out to that other person or that individual. Kind of cool. And obviously, another added benefit to this is that the attacker is performing this attack indirectly. They make this request out to an open and accessible DNS resolver, and it will respond and just send that information out to the actual target or victim themselves. The attacker doesn't really leave any fingerprints or a trace on the target. It's not reaching it directly. It is an indirect attack. You can see that here again with that syntax, but as always, Scapy is making this really, really simple and honestly really easy. Okay, now let's talk about our finale attack. I want to discuss